Friends, have you ever wondered what happens if you take an object and squeeze it? Normally, if you squeeze a sponge, it gets smaller. If you squeeze a piece of metal with enough force, it deforms and changes shape. But what if you had the power of a god? What if you could squeeze matter so hard that the very atoms inside it began to break? Today, we are going on a journey to the most extreme places in the universe. Places where the laws of physics that we study in our textbooks simply stop working. Places where a single teaspoon of matter weighs as much as Mount Everest. Today, let's understand the science of what happens when matter is crushed beyond atoms. To understand what happens when atoms break, we first need to realize a shocking fact. Atoms are 99.9% empty space. If an atom were the size of a massive football stadium, the nucleus, the center, would be the size of a small marble in the middle of the pitch. Everything else? Just empty space where tiny electrons fly around. So, why don't we fall through the floor? Why does your chair feel solid? It's because of the electromagnetic force. The electrons in your body are repelling the electrons in the chair. But in the deep corners of our universe, there is a force much stronger than this repulsion. Gravity. In our daily lives, gravity is weak. You can pick up a pen easily, overcoming the gravity of the entire Earth. But when stars reach the end of their lives, gravity becomes the ultimate boss. When a star like our sun dies, it runs out of hydrogen fuel. Without the outward pressure of nuclear fusion, gravity starts winning the tug of war. It crushes the star down, smaller and smaller, until it is about the size of the Earth. This is called a white dwarf. At this stage, the atoms are packed so tightly that the electrons are practically touching. In physics, there is something called the Pauli exclusion principle. It basically says that two identical particles cannot occupy the same space at the same time. These electrons start pushing back with a force called electron degeneracy pressure. It is like a crowded metro train during rush hour. Everyone is squeezed together, but because of their physical volume, they can't be crushed any further. 1 cubic centimeter of a white dwarf would weigh several tons. But what happens if the star is even bigger? If the star is about 1.4 times the mass of our sun, gravity becomes so incredibly strong that even the Pauli exclusion principle fails. Gravity literally overcomes the pushback of the electrons. It forces the negative electrons to crash into the positive protons in the nucleus. Think about that for a second. The electrons are forced into the center of the atom. Negative plus positive equals neutral. The atoms themselves effectively vanish. The empty space of the stadium is gone. What you are left with is a giant, city-sized ball made entirely of neutrons. This is a neutron star. The density here is unimaginable. To give you an analogy, imagine taking the entire population of the world, all 8 billion humans, and squeezing everyone into the size of a single sugar cube. That is the density of a neutron star. Because it is so dense, its gravity is terrifying. If you were to stand on a neutron star, you would be instantly crushed into a thin layer of atoms only 1 atom thick. If you dropped a marshmallow on its surface, the speed of the impact would be so high that it would release as much energy as a nuclear bomb. But friends, the story doesn't end there. There is a final stage. If the dying star is even more massive, more than 3 times the mass of the sun, even the neutrons cannot hold up the weight. There is no force left in the known universe that can stop the collapse. At this point, matter is crushed beyond atoms, beyond neutrons, and beyond our understanding of reality. It collapses into a single point of infinite density called a singularity. This is the heart of a black hole. Inside a black hole, the fabric of space and time is torn apart. Time itself slows down to a halt, and space becomes so curved that even light, the fastest thing in the universe, cannot escape. It is truly mind-boggling to think that the same atoms that make up your phone, your body, and the water you drink have the potential to be crushed into something so dense that it can bend the very fabric of the universe. It reminds us how fragile our solid world really is. The universe is far more extreme and mysterious than we can imagine. If you found this deep dive into science educational, make sure to share it with your friends and subscribe for more explainer videos. I will see you in the next video.